Here's problem number 23 and 25 from section 3.8. In 23 we're given the equation y is equal to inverse secant of x, and we're asked to find the tangent line to this curve when x is equal to 2. So let's start by finding what y prime is equal to, and then we end up with 1 over x times the square root of x squared minus 1. So the value of x prime at this location when x is equal to 2 is going to be 1 over 2 times 2 squared minus 1, which is 1 over 2 times the square root of 3. If we switch over to the calculator, we can find out that that is equal to 1 divided by 2 times root 3 close. Oops, I don't need to close that anymore, not with the new calculator. Close the parentheses now, and we have a slope of 2.886, which we will then round to 2.88, or 2.89 I should say. Okay, so the tangent line then is going to be y is equal to this 2.89 x minus 2, because we're looking at it when x is 2, and I'm going to need a y value. Let's calculate that. What is the value of y when x is equal to 2? So what is inverse secant of 2? Now this part is a little bit trickier, mostly because if we look in our calculator, we seemingly don't have an inverse secant button. So instead we're going to go take a look in the catalog and see if we can find it in the catalog. So go into catalog, I'm going to go to the S's, and then I'm going to go down that list and see if there's an inverse secant button. Send, sequential, set, and I'm not seeing an inverse secant button. So we are going to have to go to plan C, and that is, let's take a quick look in the book to see if there's some easy way, and there is what I'm looking for, that the inverse of inverse secant is equal to inverse cosine of 1 over x. So we'll use that fact. This is equal to inverse cosine of 1 over x. So let's go ahead and bring the calculator back. Let's get out of catalog mode. Second, there's the inverse cosine of 1/2, and then that tells us that this is 1.047. So we add that to there, and there we have it. If we were to distribute this through, we would get 0.829x minus, and this I'll go 2 times, and let me just go up there and get that value. Negative 5.77, and then if we add that to 1.047, so let's take 1.047 and then subtract off the 0.577, we end up getting, for our final answer, 289x plus 4.70. And you can see that that's that answer. Okay, so there's number 23. Let's do number 25 then. In number 25, we should have an easier time of this. There's our equation. Y is equal to the inverse sine of x over 4. Y prime, therefore, is going to be 1 over the square root of 1 minus x over 4 quantity squared, and then on top of that we have a chain rule of 1/4, or 1 over 4 times the square root of 1 minus x squared over 16. What is y prime then at x equal 3? It's 1 over 4 times the square root of 1 minus 9/16. See if that cleans up any. 1 over 4 times the square root of that's 16/16 minus 9/16 is going to be 7/16. I can pull that 1/16 out of the bottom, and I get 4 over 4 times the square root of 7. And that's canceled, so it's 1 over root 7. And if I check on the calculator, 1 divided by square root of 7, I end up getting a slope of approximately 378, and you can see where that's heading in the right direction. Let's finish the job. Y is equal to 0.378 times x minus 3 plus whatever y is equal to. Y, when x is equal to 3, is equal to the inverse sine of 3/4. Don't know what that is off the top of my head, so I'll put that into there. And we get that that is equal to 0.848. So I'll put that in, 0.48. And if we distribute this through x, 3 times that value is 1.134, and if I add those two values, or that positive value to that negative value, so that minus that, we end up getting 0.378x minus 2.86, and you can see that there we got that last value there. So there's our two tangent line problems.